Hello everyone, welcome to AWS Summit. How's everybody doing? We good? So can anybody tell me what this is? It's a ball? It's an animated cartoon, right? So if you haven't known what this is, it's fine, I'll give you a bit of an introduction. Now, this is from the show Star Wars, and today is Star Wars Day, May the 4th. So this is actually known as DS-1 Battle Station, also affectionately known as the Death Star. Now in the show, this is a massive super weapon designed to destroy planets, right? And you would think that something that is designed to destroy planets is actually has to be huge, and indeed it was. It is comparable to the size of the small moon. But at the same time, right, it also operated like a single structure, but also designed to do a lot of things. Besides designed to blow up planets, it's also designed to house a small navy of starfighters and also serves as a prison where some of the main characters are interrogated in the show. Now, when it was built, it is all done in a single go. There wasn't a MVP Death Star or minimal viable product where the Empire gets to iterate over many versions, discovering and fixing bugs as it goes along. And the first and only release took something like 20 years. So why am I telling you all this? Well, you know, when we are designing and building structures like that, whether that's the Death Star or a chunky, large, monolithic application, sometimes a simple yet fatal design bug or error can slip through during code or testing stages, but cause the entire system to come crashing down during production. And with that, welcome to the session on Modernise for Public Good. This is the session where we'll talk about architectures, application architectures rather than space architectures in a really modern way. Now, building modern applications is not just about technology, but a combination of the right culture and practices to make it better. My name is Tong Seng. I'm a Senior Solutions Architect from AWS Public Sector. And joining me on stage later today is Mr. Hunter Nield, Distinguished Engineer from the Government Technology Agency of Singapore. Now, we start today's session by first asking ourselves, what is a modern application? It's been a term in our industry for some time, and honestly, it may mean different things to different people. But at AWS, rather than defining what is or isn't a modern application, we like to see it in terms of the value it brings our customers. Largely speaking, a modern application allows us to move fast, deploy new releases, bug fixes, or code changes in a matter of hours instead of weeks or months. And being able to do so tends to have a huge impact, whether this is to roll out the new product feature that allows you to disrupt the market, or the latest security patch that's going to protect your millions of users from the latest CVE vulnerability. And because it's easy to roll out new changes to modern applications, you find yourself innovating a lot more as well. You can experiment with different designs and functionality to find that one that truly resonates with your users, and if you don't, simply fail fast, iterate, and come back with the next better option. Now, what's really cool is that you get to work with real users here and get actionable insights and data points that better guide your product development lifecycle. Now, building modern applications also deliver security by design. A big part of building modern applications, which we will discuss later, is the use of cloud-native services. Cloud providers like AWS take on more security responsibility on behalf of our customers. And because AWS operates at a much larger scale, and higher bar in terms of our security practices and operations, our customers get to inherit these investments directly into their application. And lastly, because with modern application, we are building in a lot more automation, particularly in the way we deploy code into production. And also we are using more cloud-native services with utility-based pricing to lower operational burden. We find that modern applications tend to have a much lower running cost as compared to their traditional counterparts hosted on-premise. So we begin our talk on modern applications by first focusing on the application architecture. Now, we talked a lot about the monolithic nature of the Death Star example at the start, but the fact is, many companies start off with having that one or two applications that run their entire business. You find that as you grow, these applications tend to grow into giant software systems with huge code bases. And by this time, your technical team is now large, but yet hyper-focused into individual siloed areas. Nobody really knows what the code base does anymore, And you find it incredibly risky that as you add code into your code base, there's something catastrophic will fail and bring down the entire system. So we can avoid all that by first thinking of our applications as a collection of individual services first. These services are built from the ground up, closely mirroring the core business functionality which they are made to represent. And this allows a good boundary to be established around what these services are responsible for. They should also be well-defined in terms of the inputs and outputs and the data being exchanged, as well as be limited in terms of the dependency it has with other services. So this is something we commonly refer to as loose coupling. Now, having these well-defined boundaries and loose dependencies will really help limit the blast radius that any bug or error can cause and help your application scale much more healthily over time. And once we start designing our applications around its individual microservices, we start to see that it makes sense to also organize our technical team around individual services as well. Now, these teams tend to be small in order to facilitate collaboration, but also be granted with full autonomy to make the best technology decisions for their business outcomes. At the same time, this team brings together members responsible for the end-to-end life cycle of the service, from design to development to build and operations. These teams will have full autonomy and full ownership of the performance, reliability, and scalability of the service. Now, you may find that there's two pizzas icon to your left, and this actually signifies what in Amazon we call two pizza teams. We have been through a similar journey of breaking down monoliths to microservices ourselves. We find that these teams tend to work best if they are not too large. Usually, a good rule of thumb is whether they can be fed with two full-size pizzas. We also start to see that many of our customers have been encouraging teams to build on the work each other have done in order to move faster and better together. This is the term known as inner sourcing, and similar to open sourcing, teams are encouraged to share code artifacts with one another and learn from them. The teams publishing code takes ownership in terms of improving the code base on an ongoing basis and adopting them for wider organization use. Any code being adopted contributes towards code reuse and is actually savings in terms of both cost and time for any future development. A more evolved form of this inner sourcing process could be the development of full-fledged internal products or common stacks, where new development can simply build on top of them without the need to worry about security or functionality or any of the contractual functionality delivered to them. Now, speaking of leverage common technology stacks and building on them, one quick way to get started is none other than on AWS itself. AWS offers a vast array of managed services to help customers reduce the operational burden of managing and operating infrastructure. Now, not only is it labor-intensive to operate and maintain infrastructure, a great deal of effort is actually spent designing and architecting for resiliency and scalability as well. AWS calls this undifferentiated heavy lifting, and this is what the cloud is here to do. You can get your technical team focusing on more business-critical work, such as writing code and delivering functionality. Going fully cloud-native also allows you to make it easier to capitalize on some of the built-in integrations within AWS services, such as those within the AWS serverless, containers, and application integration space. Now, a less talked about, but equally important aspect of adopting cloud-native is actually in the security benefits. Now, while we talk about the ability to offload undifferentiated heavy lifting to AWS, we might get some contention on the topic of security. Customers have said security is not undifferentiated heavy lifting. It is, in fact, what my business pays for. Very much so. And this is why AWS would like to partner with our customers in terms of securing them in the cloud. The degree of this partnership is flexible and entirely decided by you, our customers. So what we see here is a view of the AWS shared responsibility model, but with a little bit more color to it. The choice of different AWS services, like Amazon EC2, can offer more ability and scope of control to the customer, where for some of the more security-sensitive, confidential, or critical applications can be a better option to host them. In exchange for that control, customers have to bear more responsibility in terms of securing and configuring them. Conversely, as you start to hand off more controls to AWS by using AWS managed services like Amazon RDS and AWS Lambda, AWS assumes greater responsibility in helping our customers stay secure. Assuming greater or additional security responsibility is also an opportunity for our customers to leverage global AWS security controls. And these are certified against a wide range of industry standards. You can therefore inherit these best practices, certifications, and standards as part of your overall model for your application. Now, we've talked about the architectural considerations around going cloud native and also adopting microservices, and also organizing ourselves for success by forming small teams and sharing code. Now, we also need to make sure we can dish out new application releases in record time as well. At AWS, we talk at length with our customers about adopting continuous integration and continuous deployment practices, or CI and CD, by building automation into release pipelines that speed up deployment. Now, a typical release process generally consists of several stages, from development stage where we do peer review, code check-in at source, to the build stage where code is compiled and some level of unit testing and static analysis is done. We then move on to test, or sometimes known as the QA stage, where integration, load, and security testing is done before finally deploying code into production. We then continuously monitor them for errors and ensure that the code is functioning as per design. Now, the practice of continuous integration allows us to constantly check in code at source and carry out peer reviews and conducting some level of unit testing and static analysis. Because code changes tend to be small and done frequently and always check for errors, the impact of any error is not great and can also be easily fixed. While continuous integration stops at the build stage, continuous deployment further automates the testing and deployment process. Automated testing not only allows us to progress functional integration and load testing in a really automated way, but also test them in a variety of pre-production environment that closely mirrors actual production in various aspects. For instance, we can first deploy code into a smaller subset of your deployment environment and then scaling that over time into the full production environment, a practice known as canary deployment or one-box deployment. We can also configure automatic rollback at any point should any of the health checks or monitoring alarms fail. Now, organizations that have adopted CI and CD have reported key improvements across their development process. In the latest, or in the more recent State of DevOps report, or DORA report, which surveys thousands of developers across our industry, we see organizations experience an improvement in deployment frequency from a weekly or monthly deployment down to an hourly or daily deployment. Now, the change lead time, which is the time it takes for code changes to get into production, has also dropped from 1 to 6 months to 1 to 7 days. What is perhaps the most interesting finding of all is that the change failure rate, which is the rate at which failure occurs when new code is deployed, actually fallen from 60% of the time to less than 15% of the time. And this is unintuitive because if we generally think about deploying code more frequently, we should be breaking things much more often. Instead, we see that because each code change is small, it is often easy to spot and fix errors during testing as well as peer reviews. Whereas, if we batch up changes over the course of a month, you are more likely to not only compound your errors, but make it harder to identify which change is actually causing the issue. Now, another point to note is that these results are actually experienced by more than 50% of the respondents. And this means this is a very achievable target, regardless of your organizational size and maturity in DevOps practices. You can probably start experiencing similar results once you start implementing CI and CD. Now, to better appreciate how a modern application has made a difference, there's no better example that I can think of than TraceTogether, which is an application used in Singapore on a daily basis during the COVID-19 pandemic. Now, to share more about how this application was built, some of the challenges it faced, as well as how GovTech as a whole has implemented some of the practices talked about earlier, let me invite Mr. Hunter Nield on stage.
Thank you, Tong Sang, and good morning, everybody. So just to keep going on with a little bit of a theme, short time ago, well, a little bit closer to home. I mean, here in Singapore, at least, as the government. For us, it's a period of transformation. In 2019, we began our journey to the cloud. And, a bunch of rebel engineers perhaps won their first victory over the on-prem data centers, just to, throw it in. But it really was the beginning of a journey for us. And I'd like to run through today a little bit about the things that came together. and the things that we've discovered along the way about both application, modernization, and the use of cloud. So, we went from this kind of scrappy rebels to somewhat of an alliance in this journey. And, part of that was really looking at our evolving operating models. Now, a lot of, fundamental shifts needed to happen as we started to think about these new applications that we're building. And, that is a shift from, traditional project management to something more like agile. From outsourcing to bringing a lot of capability back in-house, bringing the brains back in, as well as some of the execution. On side of that, really, going from enablement to core functionality is a very key piece of our strategy, as well as that kind of change from, slow service requests to self-service, being able to affect change without necessarily having to go through huge change process, requests, approvals, all of these sorts of things that we're probably quite familiar in the public sector. And finally, that piece about the move from managed hosting to the cloud. So we really had this three-pronged approach to what we looked at in our journey and how we modernized our practice. And that really came down to three key pieces: platform, people, and practices. And I'll go into a little bit more detail about some of these sorts of things. So one part of that is GCC. GCC is the government on commercial cloud. And that was what we started, about 4 years ago in 2019. And it really took our experiences on-prem and applied them to the cloud. Now, that's an important starting point. We needed to start somewhere. But we needed to shift our thinking to be cloud native and to take advantage of these new capabilities that are available to us, these tools and practices that came as part of it. Now, with the help of many of my colleagues across the whole of GovTech and the rest of government, we started a cloud engineering team to really start to align our practices and improve our cloud platforms as we went through. On Star Wars Day last year, so this is the first year anniversary of launching our next generation of GCC, which took our learnings from the past few years and applied it to improve how we delivered our cloud. And that meant that we started to really crystallize a lot of these learnings, but also reapply it as to how we started to deliver. And for the whole of government, we're starting to see the effects of that about how we change how we manage governance, how we manage practices for our deployments. Now, there were really 3 or 4 key components that we started to frame out as this model for how we operate GCC. On one side, the really critical part of how we looked at handing out accounts and how we did billing across a very large organization. On the bottom, we have this really key piece about the governance and the policy, these sorts of controls to make sure that we're building out in a compliant manner. Of course, there's always the critical aspect of on-prem connectivity, which we still have a number of systems that have to remain in an environment, potentially for confidentiality or data requirements, as well as these kind of pieces to know that our systems are running efficiently and effectively, and being able to know that there are particular threats and security that align around it too. So this was our key model for the GCC platform. And that evolved as we went through to optimize various different parts of the model itself. In addition to that, on top of the cloud platform, we really started to build out another platform layer. And that's what we call the Singapore Government Tech Stack, or SGTS for short, since we all love our acronyms in government. And that was a layer above the CSPs, across the 3 CSPs that we use in our environment, to enable the organization to deliver these modern applications consistently and at scale. So SGT offers a common set of tools through building high quality, secure systems. And these sorts of things include CI/CD platforms in our tool that we call Ship Hats, container stack for delivering managed container services on top of Kubernetes, and StackOps for reliability monitoring and Apex for API management. For those in government, they're probably quite familiar with these sorts of tools, but they really round out these key components of how we start to deliver these modern applications in a way that is consistent. Now, on top of these, we started to have an app layer that provides consistent services that may be related, and building on top of that as another layer as well. and these could be authentication solutions, they could be billing solutions, other things that then build out a larger ecosystem. So really what we started to do was frame it into this, this layering of GCC as our base layer, with SGTS sitting on top of it, and finally enabling these modern applications to be built across the government. And part of that is really starting to build out our people. You know, it's not just about building platforms, we need to be enabling the rest of the organization. People is such a critical part. The practices that they are using are also such an important piece. Now, certification, I think, is the lowest hanging fruit. Early on, we partnered with all of our CSP partners, including AWS, to standardize around these sorts of things. But certifications only get you some of the way. There is that critical piece about practice, about knowledge and learning that comes as part of that. So that, for us, was really just the starting point of our journey to improving all of the different teams working on this, not only in government, but also the vendor community inside of Singapore as well. So the other part of it is really building out a digital academy for training, which became the second phase of how we started to build out and uplift our skills, not just in the cloud certifications, but in things like CI/CD, modern application development, all of these key components that can be leveraged by people and public officers across the organization. And finally, the communities of practice, bringing it all together so that we actually have these means of enablement, engagement for people inside the organization. The cloud engineering team was a prime example of that we started off early to be able to share practices, to be able to share learning. But we also started to build out things around automation, infrastructure as code, all of these sorts of key pieces that came together for us to be able to learn together, to grow together as an organization. On the other side, the practices became this other piece that we started to look at. Now, this is government. Policy and guidance is our bread and butter in some ways, and part of that was really starting to think about, you know, these existing policies and requirements that came a part of, you know, our existing on-prem infrastructure. We needed to start to think about how we modernize that, and that takes time. That takes a lot of learning to build confidence in where we're coming from and where we're going. And that required, you know, some time to really start to do that. And so what we've started to really put together is improvements in policy, looking at how we become cloud native and enable and adopt these services in the right way to give us better outcomes for both compliance and also security. In addition to that, documentation was such an important part. Now, we've always had a really great resource on-prem for our cloud playbooks, which gave really good guidance on how to use the cloud for those teams starting to adopt. But we really needed something to make it more accessible, to meet developers where they're actually working in the cloud. And so building out what we have now, which is called the Developers Portal. Now, we've talked about that in previous sessions, and it became a really key part because it was accessible, it was exposed, and it's available to anyone to view. So feel free to do a quick Google search. Unfortunately, I don't have a QR code for this, but the Dev Portal is accessible for everyone to be able to learn not just about GCC, about SGTS, but also about some of the practices, some of the pieces that we're starting to put together. So we want this to be a learning not just for government, but for the whole of Singapore and potentially the wider community as well. In addition to that, inner source, as Tong Seng talked about a little bit earlier, was a key piece. Now, you know, government, the reality is it's a little siloed, and you know, in traditional approaches, we've never really shared code. There was never really this culture, as you see in the wider internet, of open source, where everyone can access a library, everyone can download some code. And so creating that culture became a really key piece to how we started to enable that. It went from just the documentation to how do we actually start to get it closer and be able to execute, providing these sorts of key pieces. So, you know, examples of where we started to really explore around infrastructure as code templates that would help teams build out a compliant architecture inside of GCC, or container images to be able to deploy applications in a secure and hardened and compliant manner, as well as, you know, other things that really sort of started to build out around those modern applications. CI/CD pipeline templates that would really help accelerate development, alignment with DORA, all of these sorts of things we're now building out as pieces of our wider ecosystem. So that really came together and culminated as, well, you know, many of us are quite familiar with Trace Together. Now, Trace Together was, you know, an important example of how these platforms, people and practices were, you know, coming together for a really urgent response to the COVID pandemic. The Trace Together team managed to build out a modern application from scratch in a race to curb the spread of infection. As I'm sure you can probably all recall, the situation evolved almost daily, and the team needed to react constantly to the changing requirements with limited resources. There was this critical piece that we really sort of started to look at this modern approach. And serverless was a key enabler for that. The use of cloud was a key enabler, and that really allowed the team to respond rapidly. It allowed faster deployments, rapid scalability, baked-in security without any infrastructure to manage. It couldn't have really been done any other way. Now, the speed at which the team was able to respond was unheard of. From concept to production in 2 weeks. From handling 2 million requests per day to at almost 50 requests per second at peak. Many of the learnings from Trace Together and the other rapid COVID projects are now being applied to improve time to market and resiliency for other projects in government. And it couldn't have been done without a focus on cloud and the modern application practices that we've talked about today. So for us, really, it is an ongoing journey. We're going into light speed, and we're on track for 70% of systems in government to move to the cloud by the end of this year. A big, big milestone for us. There's a significant amount of lift and shift, and a lot of that now is this next bound of how we start to think about cloud-native replatforming. How do we capitalize on these modern application practices that we've talked about so that we can adapt more quickly? We're constantly learning and working with our partners like AWS to improve how we deliver modern applications and services to the citizens of Singapore. So, if anyone is interested, we are always hiring, unlike a lot of organizations at the moment. So please, if you're interested in building modern applications, reach out, please. Come and let us know. And really, I'm looking forward to being able to share future experiences as we continue our journey. Thank you very much.
Thank you, Ed. Good job. Right, so thank you, Hunter, for that fantastic sharing on GovTech's journey through development transformation and modernization. So Hunter spoke about the importance of leveling up your skills and knowledge in your organization. And a good way to get started is none other than for AWS knowledge and skills is none other than on skillsbuilder.aws. Get access to over 600 free digital courses and hands-on labs of various AWS topics. And when ready, you can start working towards some of the industry-recognized AWS certifications and demonstrate your expertise on the cloud. So thank you again very much for your time today at this track. We have many more exciting tracks awaiting you at the summit. Please leave your valuable feedback to us. Thank you very much.